So if you try and take a dinosaur bone to a carbon dating facility, they will ask, well, where do you get this from? You say, well, it's from the late Jurassic or the early Jurassic or whatever. They will
Yeah.
say, oh, no, sorry, Philip, you can't do that because they're too old. There's no carbon in them because it's millions of years old and the carbon will have decayed. It's not in dispute that the carbon 14, which is the radioactive carbon, decays with a half-life of 5,730 years. So after 70, 80,000 years, there should be none left. That's not in
Yeah.
dispute. What is in dispute is the fact that you do find it in dinosaur bones, which again supports a younger assignment to those bones.
Stephen Taylor is Professor Emeritus at the University of Liverpool, where he was formerly head of the Mass Spectrometry research group, which was responsible for the invention and development of the world's smallest mass spectrometer. He has over 280 publications and 7 patents to his name. He's also an outspoken Christian and a proponent of the idea that science and faith are not incompatible. So, Professor Taylor, thank you for joining me today.
Thank you very much, Philip.
Can you tell me, let's begin with, mass spectrometry. Can you explain to me what you do or have done and how you got interested in it?
Okay, for the Star Trek fans out there, you may recall that when Mr. Spock went to the planet and he had a tricorder with him. This is in
Yeah.
1970, and he would put some unknown material into the tricorder, press a few buttons, and the tricorder would say what it was and how much there was. And he would then pick up his smartphone and say, it's life, Jim, but not as we know it. Okay, all the older people will know that one. Um, I was a Star Trek fan too. Well, that tricorder in 1970 became a reality in the early 2000s.
So I'm talking to the inventor of the tricorder,
Well,
or
no,
as close to it as we're going to get.
no. There was a rush with trying to make mass spectrometers small, and it became a rush after 9/11 because people were looking for these portable detectors that could sniff for drugs, explosives, and other nasty things. And so that's where our invention, which was in 1996, we were heavily funded after 9/11 on the basis that everyone was looking for something to sniff for our suitcases and so on, people taking stuff on planes. So a mass spectrometer, in brief, is something which tells you what a substance is, solid, liquid, or gas, how much is there, and how it's changing in time. So it is effectively Spock's tricorder of previous year.
Can it tell you the
Well,
chemical composition of
yeah,
things?
absolutely. So in fact, it could take a little bit of mass spec, could take a little bit of your hair or your DNA, and it could give you fingerprints. And of course, that's mass spectrometry and other fingerprinting techniques are used in forensics, to determine, crime scenes and this sort of thing. Um, we use other instruments as well, of course, but mass spectrometers are widely used. When the athlete at the Olympics breaks the record by 2 seconds, and we think that was a little bit strange, we test him for drugs and so on, and that will probably be done on a sample of his bodily fluids using a mass spectrometer to determine whether he's been taking anything or she's been taking anything she shouldn't have been doing.
Now, this is a device on which, does it just pick up atoms or does it
Basically,
pick up
it
molecules?
measures the charge to mass ratio of an ion. So if you introduce a molecule or an ion or uh, a substance into the mass spec will ionize it, analyze it, and then detect it. And then these days, there's normally a, a large amount of clever software to tell you exactly what it is and compare with databases. So I think that's the thing.
So how big is this object? What's it actually look like? I mean, is it the
Well,
size of a
yeah,
tricorder?
well, you can get, maybe sort of, or you can get them in a suitcase. So the ones that were in the lab for years were huge, tabletop beasties. and larger, of course, and you still can get those. But the desire to have a portable system was very strong after 9/11, and that was what a lot of funding went into that.
So what are they
So,
mostly used for detecting? Just explosives, or what are they mostly used for?
well, there's a big push today on breath analysis. Okay, so you can breathe into it, asthma detection. There's 2,000 compounds on your breath, which can indicate disease conditions. So that would be one use. Stomach
Expensive
ulcer.
breathalyzer for the police.
Yeah, stomach ulcer. Our mass spec can tell you whether you've got a stomach ulcer or not.
Wow.
Um, and so, there's various blood tests. So you can do blood analysis. There's a lot you can, any substance, a mass spectrometer in principle can tell you what it is. So it's qualitative, and with various techniques, you can tell how much is there as well. You can make it quantitative. So that's a very interesting instrument, isn't it? And in fact, it's the gold standard for sensors because we'd love all of our sensors to be able to tell you how much is there and how it's changing in time and what exactly it is, and to great sensitivity. And a mass spec can do all of those things. Have I sold it to you?
Well, I'd like one. How much do they
Yeah.
cost?
Let me know. Yeah.
What's the price tag if I wanted to buy one?
Well, um, they vary in price. I don't think you'll get much change out of about £25,000,
Wow.
and they go up to, of course, 750K for the bigger beasties that you can get from the serious manufacturers like Waters, Thermo, big instrument vendors, Agilent. Um,
So not yet for the amateur, not something you can wear on your wrist at the moment, but
no, 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 no.
all right.
Most universities will be replete. Most with the science faculty, chemistry labs will be replete with various types of mass spec to do different types of jobs.
Okay, now you've been working quite recently with Brian Thomas and Kevin Anderson on fossils, and
Mm,
you've also produced some interesting results around soft tissue fossils in dinosaur bones. Can you tell us
mm.
about that?
Yeah. So one of the reasons for going into mass spec research, which is not what I did my PhD in, but I went into it about 1992, um, mass spec that is, because I wanted to understand mass specs are how the world became old. In other words, it was through mass spectrometry measurements on isotope ratios such as uranium and lead and rubidium, strontium that
Yeah.
rocks can be dated. Um, Come back to that later. I wanted
Yeah.
to understand that from an instrumentation point of view, and also I was interested in the question as a Christian because I don't think that anyone can fail to read the Bible or any of the ancient literature really and notice quite a big mismatch between the age of the earth as per scripture and the age of the earth in terms of the modern secular worldview that the earth is billions of years old. Um, Difficult to reconcile those two positions, though many have tried. I wanted to understand from a scientific point of view what the old Earth was based upon. And of course, it's large, those rock dating techniques largely use mass spectrometers. So I was interested to know. The question you said was what did we do on soft tissue? Well, how I got into that was one of my PhD students about 2014. Do you remember the king that was discovered in the car park, Richard III?
The third, that's right, yeah.
Yeah. Well, of course, they dated his bones using mass spectrometry, carbon dating, and they were able to establish that it was, in fact, the good king on the basis of his DNA with a surviving Plantagenet. So he was given a state funeral on the basis of mass spectrometry evidence.
Right, so mass spectrometry is used for carbon dating. I didn't realize that. Do
Yes.
you have to destroy the sample when you do it? I mean, do you set fire to it or something,
No,
or
you
it?
take you do, it is destructive, but you don't take a lot. You take a little tiny bit, a milligram or a gram maximum, a milligram, 100 milligram. You take small samples to be able to do the test because it's a very sensitive technique, doesn't need much material to work on.
Right. And then the sample itself is what? Heated up and it gives off a flame of some kind or a color, and that comes
No,
out.
the again, the way you get the sample into the mass spec or the instruments is there's a whole world of techniques for doing that. So in terms of soft tissue, so we're looking for proteins.
Yeah.
Um, and what you do is you would digest the protein using an enzyme. So a little bit of chemistry. So you take your bone, you grind it up, you clean it up, a tiny bit of bone sample. You pour some chemicals on and digest the protein that's in the bone mix with an enzyme called trypsin. And then having taken the liquid now, which has got the digested protein, you put that into the a mass spec which uses a liquid chromatography column, LC, and then the sample elutes through the column different times depending on the molecular structure that's in that mixture. And then you analyze those eluted peaks with a mass spec to give you the exact mass constitution of that sample. And what you get in practice is a lot of peaks,
Mm.
which will form a fingerprint for a particular protein or a particular sample. So what we did with the dinosaur bone, we took some modern collagen that we bought from the effectively the chemical suppliers, pure bovine collagen. We took some turkey bone, modern. In fact, it was actually from the Christmas turkey where you had some bones left. So and why not? So we
Yeah.
took some modern bone, some pure bovine collagen, and some dinosaur bone, treated them all in the same way, and matched the peaks. And what we found was that there was a match, a good match actually, for the Edmontosaurus um, collagen with the turkey bone, with the bovine collagen. Not completely, because an Edmontosaurus is different from a turkey, which is different from a bull, but enough to say, yes, this is collagen, because your collagen, my collagen, um, while it is unique to you and unique to, human collagen is unique to humans and bovine is unique to bovine, there's a certain similarity because bones resemble bones. They do the same function in the organism and so on. So we're basically made of the same stuff, but there is differences which are species specific. So we were able to determine it was collagen. Now, this is not new. There's many researchers now which have done this. The leading one is probably Professor Mary Schweitzer in University North Carolina. She's now retired. She was the kind of pioneer in this. Others in our own country. So people from Imperial College measured some dinosaur bone from the Victoria and Albert Museum in South London. They found it as well, and so we found it. So collagen, I think, is there. I don't think it's disputed. The
Is that a surprise then? Was that a surprise to find collagen in dinosaur bones?
Well, it was when it first came out, it was hotly disputed. So that when Mary Schweitzer discovered in 2007, it was no, you've done it wrong, Mary. Go and do it again. You've got it wrong, and she did do it again and again and again, and test after test after test showed that it was collagen. And then people began to take note, and then she did what was called she sequenced the collagen. So you've heard of perhaps DNA sequencing and so on.
Yep.
Yeah. Well, collagen also it's made up of amino acids, and it's got a kind of similar structure, though not the same as DNA, but it has got these amino acids which come in sequence, and
Amino
you can
acids are the building blocks of proteins, aren't they?
yeah, amino acids, the building blocks of proteins. So collagen is a protein, so it's got its amino acid building blocks, and those building blocks can identify particular organisms. So what Schweitzer did, she took a dinosaur bone. She took a T-Rex and a Brachylophosaur had hadrosaur. Brachylophosaur canadiensis is the technical name, and she sequenced it. And she published this as sequence protein. So not just collagen, it's sequenced now to a dinosaur. So it's specific to a dinosaur. She did that. What we did that attracted attention earlier this year was to take a different dinosaur from a different place, a different time period, but the same type of hadrosaur, in other words, same species, if you like, and find that the collagen sequences matched. So that is like a finding a fingerprint match. And that was deemed by the community to be the first independent confirmation of Schweitzer's results that this is dinosaur collagen and it is endogenous because it's very
Okay,
difficult to endogenous being original to the dinosaur. It's not being washed in from
from
somewhere,
somewhere.
or it's not being introduced by a researcher into the laboratory or anything like that. It's not contamination.
So that's pretty solid evidence for that. But tell me, why is the finding of collagen in dinosaur bones so controversial?
Well, simply because the age assignment for those fossils is 65 million years plus,
Mhm.
and collagen is a perishable material. If we, to bury a skeleton in the back garden, well, then after 20 or 30 years, under normal processes, um, you wouldn't find much left. After 100 years again, if it's a large, you can find skeletons of people after a certain amount of time. But uh, basically, 1,000 years, your chances are diminishing rapidly. 2, 3, 4, 5, 10,000 years, really small. 100,000 years, and of course, a
Okay,
million
so
years.
we've got a problem then,
This,
because
yeah,
if you age your dinosaur bone on the basis of extractable collagen and say that it's quite not quite as old as we thought it was because collagen perishes, and then you age it on the basis of, I don't know, its carbon isotopes, you'll come up with two entirely different results, though, won't you? So how do you join that circle, or solve that paradox?
I think, if I may be so bold, um, people don't date rocks using carbon dating.
No, bones,
They
dinosaur
don't
bones.
normally date, they would not normally date dinosaur bones with carbon
Oh,
dating because they believe they're far too old for carbon dating.
right.
So if you try and take a dinosaur bone to a carbon dating facility, they will ask, well, where do you get this from? And you say, well, it's from the late Jurassic or the early Jurassic or whatever. They will
Yeah.
say, oh, no, sorry, Philip, you can't do that because they're too old. There's no carbon in them because it's millions of years old and the carbon will have decayed. It's not in dispute that the carbon 14, which is the radioactive carbon, decays with a half-life of 5,730 years. So after 70, 80,000 years, there should be none left. That's not in
Yeah.
dispute. What is in dispute is the fact that you do find it in dinosaur bones, which again supports a younger assignment to those bones than is
Let me just
commonly done.
get this clear. So carbon 14 has got a half-life of, what did you say?
5,730 years.
And therefore, there shouldn't be hardly any remaining after, well, certainly the length of time of the Jurassic period, which is millions
Yeah,
of years. But you're saying that you do find carbon 14 within dinosaur bones, particularly in this collagen probably area, and that suggests that the dinosaur bones are not as old as we think they are.
correct.
How come that's not more widely known? Because surely it's quite easy to find out whether carbon 14 is in a dinosaur bone or not.
No, it's not so easy. I mean, this technique's not, it's not that easy to do. There is, I think, a reluctance from labs to test for dinosaur bones on the basis of their understanding is there won't be any carbon 14 there. The bones, not all the dinosaur bones do contain the carbon 14. Some of them are in such a bad state that no carbon 14 is detected. So I think Schweitzer did try and test for carbon 14, didn't find any.
Right.
Our results have been different. We have found carbon 14 in dinosaur bones. Um, and the normal explanation, if you like, from the secular community is, well, it must be contamination, the carbon 14. It's contamination by a
Yeah.
modern source of carbon 14.
Yeah, I
That's,
was just going to say that.
yeah.
Surely that's what people would say to you.
Yeah. And in fact, they would regard the presence of carbon-14 as proof that they must be young, because we know they can't last there for a million. They think millions of years old, therefore there can't be any 14 there. Therefore, if you find some carbon-14, it must be contamination. That's the way that argument goes.
What's your response to that?
Well, I think it's very difficult to argue for a contamination scenario for what we have done. You see, there's another way to date bone, and that's you can date bone using the carbonate fraction, which is inorganic, but carbonate's got a carbon in, called the apatite, or you can date the bone from the collagen, which is the organic fraction. And we've dated bones using both methods of carbon dating and found concordance between the results. That's quite difficult to explain on a contamination scenario. Consider the contamination scenario. Some groundwater or whatever has filtered in and contaminated these bones and given us a carbon-14 signal using an inorganic technique. And then, oh, some groundwater's filtered in and contaminated the organic molecule, which is very different bond strength to the inorganic one, to the same level of dating. It starts to become special pleading, actually. And so that's an ongoing experiment. All I can say is you've asked, and that's the answer that I would give. We're finding carbon-14, not tested by ourselves, I hasten to add, tested by other laboratories. We found carbon-14 in dinosaur bones, and we would love to have an ongoing collaboration with a carbon dating facility who'd be willing to do any controls or tests that they would like in order to be able to verify, that this is correct. Of course, it all costs money, of course, because carbon dating facilities are not cheap, but neither are they. It's not cost prohibitive. If you have a few £1,000s, you can get an experiment done which would prove this.
Let's suppose for a moment that what you say is verified and that there is carbon-14 in dinosaur bones. What are the implications of that?
I think the first implication is that the age assignment for those fossils is not correct.
What would it more likely be then? Instead of being millions of years, you're talking about what?
I think the let me put it another way. The age assignment, I think it's the carbon-14 test, in my opinion, doesn't tell us the exact age of the bone. All it tells us is that they're not millions.
But surely the ratio of carbon-14 to carbon-12, coupled with the half-life of 5,000 years, should tell you the exact date.
That's based on the assumption that the ratio of C12 to C14 in the atmosphere has remained constant over the time period.
True.
So with all of these dating techniques, you have to examine the initial assumptions.
Yeah.
And I mean, you look at the literature and that's what you find, that things which are dated by one technique 1 decade are redated by another technique or a more accurate take. That's the story of carbon dating, and it's the story of radiometric dating, actually.
Yeah.
You have to examine the assumptions on which the thing proceeds.
But come back to this point here. What you're then saying, or as far as you're prepared to say, is that the dinosaur bones, certainly the ones that you've been working with, are not millions of years old. They are thousands of years old, which is quite a few orders of magnitude different here, 3 orders of magnitude at least.
Certainly less. According to the carbon date, the maximum that you could have for a carbon date is 100,000 years, and that's pushing it.
Okay, but
so the oldest carbon dates in the literature are 70, 80K. So
but the implications of that are necessarily huge, are they not, for a whole realm of paleontology?
Yes, I suppose so. Though it could be argued that we've got a rogue bone.
A rogue dinosaur who
Yeah.
lived a bit longer than all the others did, you mean?
I mean, all you can say is some of the samples that we've tested, and not all of them, some of them are not carbon dead.
Yeah,
And some will explain that on the basis of, well, you've done it wrong, Steve. There's contamination. You haven't been careful enough. And some will have explained it on the basis of, well, there's no carbon there. We told you so. That's because they're millions of years old. I mean, both explanations are possible and plausible, aren't they?
Hmm. Could it be that you've got a different kind of bone, like a mammoth bone, maybe, which would have been,
Yeah,
yeah,
that's also possible. Wrong
yeah,
identification of the bone. The one that we used for the paper published in January, you can see the photos in the paper. It's ginormous, and it
right,
was it's definitely a dinosaur bone, 22 kilos, and that produced collagen that was sequenced and that matched, and so my hadrosaur, and it matched the collagen that Schweitzer found in her hadrosaur. So that's an argument for endogeneity of collagen in that particular dinosaur species. And
right.
of course, that's all. There are others who've proven it for um, other creatures and so on. But yeah, it's always a limited data set, isn't it?
Okay. Let me widen this whole thing out and ask you about something related but different. I believe you're a supporter of Answers in Genesis. Now, Answers in Genesis is a well-known organization fronted by Ken Ham that proposes that the age of the Earth is not the 13 billion years that we're led to believe by mainstream science, but rather is thousands of years old. Is um, your support of that organization influencing your science in any way,
Okay.
or is it the other way around?
Firstly, a factual error.
Okay,
It's
put
the
me right. Put me right.
it's the age of the universe, which is said to be 13 billion or so, 13.6 billion, though it is increasing a little bit recently.
Weren't we
It's
just down to a little
it's
bit less?
4.2 billion for the age of the Earth is
Oh,
from my
that's right.
knowledge.
Yes, you're
Yeah.
correct. Yeah,
And you've
sorry.
got a
I knew that.
500 million year geological column,
Yeah.
of which you find soft tissues all the way through. I am a Christian, so I do take the Bible seriously. And actually, I do see it. There is a disconnect there between anybody. I mean, you don't have to be a genius to see that the Bible, on its taken its face value, is giving you a much shorter age for the Earth. Now, you're faced with you can do two things. We can regard science as being magisterial. Science has got the truth, and the Bible's wrong, basically. And we need to, let's get real. We need to import those dates and find how we can reconcile um, our Christian faith with millions of years. We can do that. What Answers in Genesis seeks to do is to take the other perspective and say, well, actually, some of the data that's out there is more supportive of a younger time frame for the Earth, and in actual fact, consistent with a biblical time frame of thousands of years, and highlight that evidence. And that's the position that I take actually. Um, so yeah, so that I think that sums it up. It's also worth saying that my predecessors in electrical engineering and electronics in 19th century physics, and before that, many of the great scientists had no problem at all with the biblical age of the earth and doing great science. And post-Reformation history will bear that out quite a lot. Isaac Newton, Johannes Kepler, Michael Faraday, Clerk Maxwell, and so on and so forth. These were all Bible-believing Christians, as I would claim to be. And so it's no break upon good science to be a Christian. And I would like to make that point. Is it possible that science has taken a wrong turning on the age of the Earth? Is that a possibility? Would people be willing to allow that, or to discuss that, or even consider that? Well, if we say we have an open mind, we should be open to evidence which challenges our worldview. And I would put that respectfully to those who would say, well, we know that the Earth is 4.2 billion years old. How do we know? And why do we know? And what's the basis for that epistemological claim? That would be my pushback to them.
Okay, let me try and pin you down a bit, though, on this. How old then is the Earth? I mean, are you in the same camp as Archbishop Usher, who calculated the age of the Earth from all the genealogies and got it back to 4004 BC? Or do you have a less precise point to that?
I'm very comfortable with the biblical age of the Earth. Why so? I don't believe the Bible is an ordinary book. I don't believe its origin is from man. I think its origin is from God. I also think that when you bring God into the picture, the God of the Bible is a miracle working God. And if you look at the creation miracles in the Bible, whether done by Jesus in the New Testament or those recorded, say, in the book of Genesis in chapter 1, you don't need vast amounts of time to create. In fact, what normally happens is God creates instantaneously. But that which he does create, that which is created instantaneously, will have an appearance of age. Can I give you an example?
Please.
Jesus at the wedding of Cana in Galilee, they ran out of wine. His mother says they run out of wine, and they tell the servants to fill the water pots with water. They go down to the well, they fill them with water. They take it to the governor of the feast. This is according to the eyewitness account in the Gospel of John, and who's there at the time. And they get this wonderful cup of wine. The Creator has done a creation miracle just like that. Normally it takes a long process to produce wine. But when the Creator is there, that which took a long process is done miraculously. I think we apply that same logic to the book of Genesis. And you find, therefore, that what would take, if we were just trying to account for the universe by naturalistic means, and we would take God out of the picture, oh yeah, you need billions of years to explain how you get these light years and so on. If you take God out of the picture, yes, you replace the God of the Bible with millions of years. But you don't have to do that. Neither should you do that. If you're a Christian, if you believe God is all powerful, what's the problem with God doing it like that?
Can I just clarify what you're saying here? There was a guy whose name escapes me now, who wished to reconcile fossils with a young Earth and said, how did they come to be there when they've been buried down so deep and they appear to be so old? And his answer was that God created the Earth together with its history and together with its fossils. Is that the view you're
No, no, no,
presenting?
no, no. What you find in the fossil record. So let's take soft tissues, dinosaur soft tissues. So you've got 500, according to secular data, you've got 500 million years of geological column. Yeah, roughly. Cambrian 2, Precambrian 2 to today. And it's full of fossils. And there's fossils right the way throughout that column, which contains soft tissues. And they're published in the scientific literature. The oldest one I'm aware is 505, said to be 505 million years old, soft tissue. Okay? Now, soft tissues can't last that long. What you also find is when you look at the fossils, say, of a dinosaur, and I've done this, a dinosaur that's said to be 65 million years old, and one that's 78 million years old, and the one that's 199 million years old, and you look under the microscope, you find collagen in all of them, and you find an appearance, you find bones, both bone cells, osteocytes, soft tissues in all of those. So you can account for all of those fossils, which are, by the way, other point, again factual. Those fossils are found in sedimentary rock,
Mm.
which is rock that's laid down by water.
Yeah.
So you've got here, there's sudden death, sudden burial, jellyfish, sharks alongside with dinosaurs, alongside with other things, all mashed up, mixed up together, and they all look the same. Yes, you can try and explain that with a slow and gradual process of evolution over 500 million years. Or you can say there was a watery catastrophe that destroyed all life on this planet not very long ago. And that's what's responsible for fossils on sedimentary rock on the tops of mountains like Everest that all looks the same, that all has collagen, that all has soft tissue, and that dates young. That's what the science says.
What do you say to those people then who say, okay, we find that collagen is present even 500 million years ago, so we made a mistake. But the mistake is this, that we thought that collagen could not last that long, and now we know that it can. And
Yeah,
that will maintain our age profile. It's just that we have to reassess our understanding of how long collagen can last for.
yeah, that's the usual thing. By the way, it's not saying that collagen is lasted 500 million years old. The oldest assignment I'm aware of for collagen is 199 million years old.
Okay.
Okay, so the sponge that they found in the Precambrian one, I'm not sure what it was, whether it was collagen or not. I don't know. I have to check it out. But definitely the one I'm aware of, collagen in 199 million year old crocodile. Yes, the other alternative is, isn't this amazing how collagen can last for 199 million years? There must be some wonderful mechanism that we don't know of yet, but we're going to find out. That's how this persists.
Yeah.
Two problems with that argument. Firstly, it's a God of the gaps argument. We haven't found it yet, but we'll do so.
Yeah.
Secondly, it's a it's I would say there is the paradigm or the worldview is driving the interpretation. In other words, we know that these are hundreds of millions of years old, therefore let us find an explanation. But contra the great age is thermodynamics. Soft tissue can't last 199 million years old, 199 million. It just can't do it. Thermodynamically, that doesn't work. And so thermodynamically, there's a good argument to say that this is not that old.
Okay. Let me put another point to you, but this time from the other end of the spectrum, which is from the faith spectrum. There are
Mm,
many people who would claim to be Christians, and there
mm,
are many people who would claim to be Bible-believing Christians.
yeah,
When they come to the book of Genesis, for example,
mm,
the book of origins, they'll take it to be that this is a collection of stories that tell us
yeah,
very important truths about our origin, but it's not meant to be taken in a scientific and and dated kind of way that tells us the age of the earth. Can't, I mean, in fact, I would say most Christians that I know of would take that kind of a view. What would you say to those people, and why is it so important to take Genesis in a literal way?
Well, I think we got to ask ourselves here, do we follow Christ or not? How did he take Genesis? When they asked him about marriage, for example, and he said, from the beginning of the creation, God made male and female. Therefore, a man shall leave his father and mother and cleave to his wife. In other words, to settle a question about marriage, Jesus went to Genesis and he's claiming two things. Firstly, he's claiming that Genesis is authoritative. Secondly, he's claiming that Genesis is true. There was a man and there was a woman. Thirdly, he's claiming it they're from the beginning, not billions of years, 13 billion years after the beginning. Now, is he telling the truth? Is he misguided? Was he really the Son of God who just got it wrong? Is he misleading us? I think when you think about those questions, you have to decide what sort of a Christian you are really. Are you going to be one who follows Christ in his interpretation of the Bible, or are you going to be one who's saying, well, when it came to science, Jesus got it wrong, really? And we now know that, since the time of James Hutton and Charles Darwin, we've now got a better handle on this. Um, it's the atheists who've told us how we got to interpret the Bible. We've got to follow those. I would beg to differ with that, actually. So I would say and that's if effectively what you know, thinking how did Jesus interpret Genesis is a very important question, considering who Christians believe that he is. And also, it's not a matter of science. Genesis is not meant to be a scientific textbook. It is meant to be a book of history. That's the point. Is Genesis history or is it a false history? And that's the question I think we have to answer. And what is the intent of the author? Authorial intent is very important, particularly in ancient documents. What did the author of Genesis, Moses was the one who collected the documents together, though I believe he worked from pre-existing accounts. What did he want us to believe? Did he want us to believe that God made the world and everything in it in 6 literal days? Or did he want us to believe something different? And I think when you ask those sort of questions, authorial intent, authority of Jesus, purpose of Genesis, nature of the writing, history, you do come up with the point of view that it can be taken, it can be believed, and I'm one of those who just is a believer.
But what about those people who would say, well, yes, Moses may have had that authorial intent to say it was made in 6 days, but Moses wasn't a scientist, and unfortunately, he didn't have a pocket spectrometry.
Mass spectrometer.
Yes, to check things out for himself. He was just presenting the story as best he could.
Well, Clerk Maxwell had no problem believing in Genesis, and he's a far greater scientist than I am. And so the point is this: is the Bible from God, God's word, and therefore inerrant, infallible, clear, or is it something that Moses and his mates cobbled together years after the event? Christians, the church for centuries has believed the Bible is a divine book. It's come from heaven. It's God's revelation. It's God's self-revelation. So the Christian perspective is God reveals himself through creation. He reveals himself through Christ, God incarnate, and reveals himself through Scripture, the Word of God. And that is the basis of the Christian faith. If we undo those things, I think our faith collapses eventually. And isn't that what's happening in Britain today? That the church, by and large, has lost its biblical moorings, its belief in Christ as the infallible, sinless Son of God, who died for our sins and rose again on the 3rd day. And in fact, that it's all something that we can pick and choose what we want to believe. That doesn't work for me.
Tell me, what kind of reaction have you had then when you present these kind of ideas, coupled with your strong commitment to science and your strong commitment to your Christian faith? How does that sit with your colleagues at work? Have you had any kind of pushback from that? How do they treat you on the basis of marrying these things together?
I've got excellent relationships with all colleagues at work. I've had robust discussions with fellow professors. I remember one in particular from the life sciences department and so on, who have a different worldview, and we respect one another as colleagues. But I'll never forget, I work in an engineering department, and most engineers, they know good design when they see it. And it's a very easy case to make to an engineer that this world and that the human body and that the systems around are a well-engineered design. The case for design, to make that to engineers, is an easy one, actually. And I don't know, I'll be honest with you, I do know some, but most engineers, I would say, are very open to the idea that there's a master engineer who engineered the universe. It's not a difficult case to make.
What's your view of Stephen Meyer then, and the intelligent design people, David Belinsky of the Discovery Institute? Have you come across them?
Yes, I have, yeah. Never met them personally. I would say they're doing a great job in that sense that they're arguing for design. I'm saying they're not going far enough, that they should be also willing to consider the scientific evidence for a much younger Earth than is currently believed. And so I would, I would, that would be my challenge to the ID friends, and I do count them as friends. Their arguments are very powerful, but they're not going far enough. And actually, if I was honest with you, Philip, I would say most people in their saner moments, more reflective moments, will actually admit that they are believers in God. The atheist community is a minority on planet Earth. They do have the microphone and they do, or the megaphone, and they do have control in the Western world of the education system, which is sad to me. But I think that actually atheism will fail as a philosophy, as a religion, because it just doesn't have the answers that people need. And there's even some evidence of that amongst our younger people, Generation Z today, I believe, with a greater awareness and desire to know a little bit more about spiritual matters.
We've come roughly to the end of our time, and it's flown by for me. But can I just ask you one last question? That is touching upon what you've just said, and that is, we do have young people coming along who want to be scientists. Perhaps they even have a faith of their own. Do you have any advice for people like that, and maybe navigating some of the difficulties that they may face in a scientific career?
Yeah, I mean, I'd encourage. My view of Genesis is that man was put on Earth to have dominion by God. It's God's purpose for man to subdue and to have dominion over the earth and to be a guardian, at the same time a guardian of Earth, and not to exploit it and so on, and to trash the planet, to look after the planet, to tend the garden, to look after it, but also to uncover its secrets and use them for the benefit of others. So I would encourage any young person to go into a scientific career. No problem at all with that. To have that inquisitive nature, I think, is given to us by God. We're meant to discover. We're meant to look at the stars. We're meant to consider these things. And I would also encourage any young person. We live in days, I would say, of anti-Christian thought, atheistic paradigm, worldview. I would encourage them to look at the massive evidence that there is for Christian faith. And the place we start there was with the person and work and the resurrection of Jesus Christ from the grave. If that is true, and I think it can be demonstrated beyond any shadow of a doubt from the history, from the evidence that we have, then that changes everything and it needs to inform our scientific thought as well.
Professor Steve Taylor, thank you very much indeed for a very interesting conversation today. Thank you.
Thank you.